actually working. But without further ado, Blackmon.
How's everybody? I have to talk really loud. Okay. Thank you for showing up. I know it's pretty juggle. Same my coffee. Can't see slides. Well, while that's working, a little bit of an overview of what we're doing. Well, you might not know who I am. So my name is Sabree Blackmon. I'm a security engineer at Docker. I'm sort of responsible for product security. There we go. That's me. Product security, the application security stuff, and all of our stuff and some of our open source things. But a lot of what I'm doing at Docker relates to how do you secure things around your applications, including telemetry, metrics, how do you do auth and secure your logs, and all a bunch of concerns that some of them have to do with each other, but some of them don't. So today we're going to talk about how do you secure your telemetry and tracing. That's kind of a new fangled hipster way of saying metrics and logging, but it is what it is. This is a talk I gave at KubeCon a couple months ago. I'm going to do this in a really informal way, hopefully. So if you have any questions, just yell at me, please. So first things first, our apps are generating an actual shit ton of data. And this is generating a lot of really new concerns. Operational data such as performance metrics and infrastructure. A lot of this stuff isn't new. Prometheus is a fairly new thing for a lot of companies here, but it's been out for a while, and time series metrics are definitely not new. So we're going to go a little bit into the different kinds of application generating. Some of this data is auditable. So there's application access logs. See if I can juggle things here. And this is a tweet from Charity Majors about kind of overview some of the differences between auditable data and operational data. Both of these kinds of data are really interesting, but the application security and information security concerns of both of those kinds of data may be a little bit different. Auditable data may have things like, transaction logs and replication things. Tracing often goes auditable. Operational data is something that's more for people who are working in quote-unquote DevOps, who are actually. So, engineers, but also auditors, InfoSec teams, and business folk leverage this data for a diverse set of concerns. As such, this data can have an extremely large value footprint in your entire organization. All right, but what happened when this observability data leaks? That's a mouthful. This could be accidentally to the public. It could be captured by bad actors. We have a lot of prominent examples of this. Could this damage reputation? Can this give information to your competitors? There's a lot of really sensitive infrastructure data and a lot of these things. So this is another tweet. This is by Scott Helm. This was a little bit more recent last year, but GitHub and Twitter recently had some personal information leak in their logs, and even if those sorts of things are kept internal to an organization, you don't want users' passwords floating around in plain text. And this stuff is so common that there's actually a CWE, which lists a lot of different, very similar to CVEs, but these are more application specific. And so this is a great website to kind of look at secure practices for developing your applications and your infrastructure. And this one in particular actually goes into information exposure through your log files. A lot of people don't look at these sorts of things, even if they're behind lock and key, storing things in plain text, even if it's such like a social security number or user password hash or something like that, could be bad. So within CNCF, we have a lot of great open source observability tools, Prometheus, Open Tracing, FluentD. But there isn't a lot of guidelines on how to protect this data in transit. This assumes people even know how to protect this data in transit in the first place. So I'm going to go a little bit deeper into observational data types. Oh, yeah. Missed slide. This data often needs to be secured at rest too, but that's a different talk. The talk is primarily around transit. So time series metrics. This is often what we refer to as telemetry. If you use Prometheus, that's basically what this. And so you expose different types of numerical metrics. Some of them change over time. Some of them are sums. It kind of depends on the information that you're capturing. And from a security perspective, this information can be useful in determining how apps behave in response to API events, time of days, et cetera, and leak a lot of operational data. But it can be used generically for any kind of metric, any sort of number that changes over time. It can be captured with these tools. In our example app, we use time series data points for application access and security statistics. That's a very weird way of saying heuristics, but that's particularly sensitive data. Text logging or logging. Logging can be structured or unstructured. A lot of the logging that you traditionally think of is unstructured, meaning text files and things like that. But structured logging via JSON and others. Right, so logs give engineers context information about events within an application. So our example app, for instance, writes to the log anytime authorized access of data or if someone fails a login. So some of this logging is relevant for app debugging purposes. So tracing, you may do simple printfs that are captured by your Docker runtime, spit out to Fluent. But some of this logging is also needed to audit ACLs or access control, or security events, data, reading, writing, et cetera. So that second bullet point, traditionally we've separated trace and or debugging application information from ACLs and security events and other things that need to be auditable and stored forever, but they often get conflated. Tracing. So our example app doesn't actually use tracing in a whole lot of depth outside of logging, but there's another system that's often seen as an extension to logging, but it really isn't. So just a show of hands, how many people have used tracing, application tracing? Tracing, Jaeger, Pipkin. It's really cool. So if you haven't looked it up, I would highly recommend. But traces are not constrained to a single application, right? And so tracing or distributed tracing bring together events across a distributed call stack, which is a very convoluted way of saying if your application calls another application, that call itself can be brought together in. But it also ties in infrastructure-specific information into each trace, and so IP addresses, host names, those sorts of things are often brought into the trace information. Proxies like Envoy, Nginx, I think Apache has a Zipkin add-on, but I'm not entirely sure, can contribute to data. So as data travels across your infrastructure, it's actually contributing information about Envoy particularly, contributes a lot of time metrics, caller information, header information, and stuff like that at the layer 5 layer that you may not see within your application. And again, things like IP addresses or host information can be exposed, and depending on how your infrastructure is structured, that stuff can be particularly helpful for people who are trying to plan attacks. And last sort of bullet point about tracing, application-specific context information can be added to traces. This is called baggage. This baggage travels between each hop-ish. The actual implementation of that is a little bit different. But there's no data sanitation or transport safety across trace baggage. Passing information across in that trace baggage, it's unencrypted, it's in plain text, it's not for more sensitive. So, catch up on my. All right. These tools are all great for debugging and observability purposes, but there are important application security and information security concerns around all of this data. So bad actors can gain valuable introspection into how your applications behave, but the cost of information leaks increases the more useful we make this data to engineers. And so capture a lot of detail because you want debugging and troubleshooting to be easier. That detail can be extremely valuable to attackers. And so this is a demo case study, and this is where the fun happens, because I have code to show you guys. But we have a simple application that I'm going to use to demonstrate a lot of these things. It's a very simple HTTP API that sits in front of etcd, which is a key value store, in which you can store text secrets. I use that in a quotes because they're not encrypted and they're plain text and they're not actually secrets. So don't use this ever. And there's a simple username and password login that generates a token, and that token is then used for your API access, and we'll go into that. And so this application has a Prometheus endpoint that scrapes and, well, excuse me, that Prometheus scrapes and it pulls that exposes application access statistics. So we have 4 endpoints for number of valid logins, number of invalid logins, secret set, and number of secrets accessed. And so I'm going to show you guys where that is. I should be able to just, there we go. Can you guys see that? Ish? Okay, very cool. And scroll down. And so here we go. So we have a bunch of Prometheus objects. If you don't know Rust, that's fine. This is pretty simple to follow, hopefully. And so we have quite a few Prometheus counters, and counters are exactly what they sound like. They start at 0 at the start of your application, and they increase into infinity basically as your application runs. And so we have a bunch of different metrics here. Like I said, secrets fetched, login failures, access denied, et cetera, et cetera. And so at Docker, we use a lot of these sorts of simple metrics to track information that's useful for security purposes. And you can apply some machine learning and forecasting and a whole bunch of other stuff around this stuff. So, it's really interesting information potentially, depending on what you're using these metrics for. And so in our use case, preventing tampering and establishing trust is very important. The last thing we want is someone to sit in the middle of this access denied counter and make it appear as if there hasn't been any events. That completely ruins our metrics, and if we have any alerting or something like that, none of that stuff is going to work. Right. How many of you guys have seen Prometheus before? Okay, so I'll show an example of what that looks like. It's kind of ugly. which is why I don't like showing it to people, but does exist. And so this should have I haven't done a whole lot. This is I just started up this application, but you can see we have simple secrets is sort of the name of our metric, login failure total, and the value is here. It's nothing pretty. Usually, if you're operationalizing any of this stuff, you would put something in front of these metrics, like Grafana or insert any number of things. This is extremely simple, but it is useful. All right. I'm just going to do this in window mode because this is easier. All right, so the application also uses FluentD. FluentD is sort of a log forwarder, if you can imagine. It takes a stream of logs, usually structured logs, but you can also use it for unstructured purposes, and pushes those things to, you can use FluentD for Splunk, or you can use it for Kibana or anything like that. In this case, it's just using FluentD. And so our application pushes auditable events to FluentD, logs access events and system errors in detail. As such, valid or invalid user identities are exposed. This is a little bit contrived. You shouldn't ever do this, but for our example, we do have this function here called audit events, and it captures a bunch of information and it pushes it to, or posts it to FluentD. And so the important thing to see here in our main, we audit server start with the SPIFFE ID, and I'll get to what that is later. We're auditing login failures for user due to invalid password. We're auditing session tokens when they're created, and so login success, et cetera, et cetera. This is great for tracing, and it may be required depending on your application domain. You may be required to track these sorts of things, but of course, this is particularly sensitive information. I'll show you what that looks like as well. Right now, I'm just pushing to a file, and in this example, we have the date, the SPIFFE ID of the application, and then very simple log output with the tag and the message. All right. So this is a little bit of an overview of what the application looks like. We have this API that sits in front of etcd 1, 2, and 0, 1, and 2. There's a Spire server, which I'll get to in a second. But we do have these proxies. These are Envoy proxies that sit in between Prometheus and FluentD. So show of hands in the room, how many people have used Envoy before? Okay. How many of you guys have used Nginx or Apache? It's basically the same thing. So if you can think of being able to put a rich API in front of Nginx, that's kind of what Envoy is. And so it's used to be reconfigurable at runtime and reconfigurable without loss of data. And so it can drain connections and establish new connections without losing any data, without dropping any packets. Very effective and efficient at that. But you often use Envoy to establish TLS. And so if your application doesn't necessarily understand TLS natively, you can put an Envoy proxy in front of it to secure transmission of data in between your application and the next hop in that process. That's an extremely common use case, so much so that Istio, which is a service mesh that's gaining a lot of popularity, uses Envoy for its proxy. SPIFFE is an interesting technology. Show of hands, people who have heard of SPIFFE. that's a lot more than I was expecting. So SPIFFE is, actually, I think I have, do not. SPIFFE IDs are this open standard. It was established by Joe Beta and a bunch of ex-Googlers, oh boy, 3 years ago? 2.5 years ago. Hopefully they aren't watching this. And SPIFFE IDs are an open standard to create a simple but open source standard way of identifying applications. Application identity is kind of a new field of engineering because as applications are becoming a lot more ephemeral, as we're moving to platforms like Kubernetes and Swarm and things like that, host ID, IP addresses aren't useful anymore. If applications can spawn on any number of hosts that are spun up and down or scaled, you can't really use IP addresses to establish application identity anymore. And so these SPIFFE IDs are these X509 certificates, which is a pretty generic form of SSL TLS supported certificate that are securely issued through a process called attestation with the Spire agent. That's a mouthful. Spire is the open source implementation of SPIFFE, but there are other companies that are implementing SPIFFE IDs as part of their process. Istio uses SPIFFE IDs to establish identity with its applications. Console supports SPIFFE internally now. And so it's being supported by quite a few different vendors. So SPIFFE IDs are identities that are tied to a specific host system, and they're rotated automatically, regularly for you. In this demo, I think the expiration for these SPIFFE IDs are every 2 minutes. And we're actually using these X509 certificates to create SSL. And that's what this next slide is. And so these SPIFFE IDs, because they're just X509 certificates, can be used to establish TLS connections between applications. In our example, we're using them to create TLS tunnels between the application and Prometheus and FluentD. The really cool thing to note about SPIFFE IDs, which I don't have a whole lot of information here about, your SPIFFE ID is tied to a specific application. I kind of mentioned attestation already, but your SPIFFE ID is cryptographic proof that your application is who it says it is, right? And so once it goes through that process of, hey, I am who I am, I'm proving that application B is actually application B, it's running on host C, which is allowed to run application B. This SPIFFE ID is cryptographic proof that you can present to other systems and say, hey, this is who I am, but you can also use it for TLS and SSL. And so, because we're establishing this cryptographic link in between our application Prometheus and FluentD, we not only are able to encrypt data in transit, but both FluentD and Prometheus can be sure that the data is coming from a trusted source. If you want more information about running the application, there's the GitHub for it. The code is not that great. I'm in the process of fixing it up, but there are really good instructions. So if you do want to play with it, that is the repository. And now I'm going to go into a little bit of a code example. So hopefully I can balance this microphone with my screen. Actually, before I go into the actual example itself, are there any questions? That was a lot of information. Anything? Awesome. Let's do this. How much time are we? Very good. So, I hate MacBooks. All right, we're full screen, so I can't do that. All right, there we go. So this is Postman, which allows you to basically test APIs. Simple Secrets is a very simple API. I have a bunch of requests. That's weird. A bunch of requests on the side here that I just stored, so they're really ready to reuse. This is in the Git repository, so again, if you want to play with this application, these requests are already pre-made for you. Don't want to get too far down the rabbit hole, but like I said, there's a login API. You hit the login API with the username and password. It generates a token, yay, and that token is then stored in that's not it. Try again. Is then stored in etcd, and then you can see the session tokens here. So it's creating tokens which we can then copy and paste to set secrets. So the token. And this uses a pretty straightforward URL format, increase the size of that, to set secrets. So this is setting new secrets to sample value, send, gets a 200 back, go to etcd, open up secrets, and there's a tacos and beef in here, not sure why, there is. And then there's a new secret, and so we can create secrets into infinity. There's also a bunch of bad or invalid requests here, and these are actually the interesting ones. And so we can attempt to log in with an invalid password, you get a 401, yada, yada. We can attempt to set a secret with an invalid token. This is just, nonsense. And so we're trying to set a secret of new secret to value or something like that. Of course, we get a 401, and we can try to get some secrets here without a valid token, and get a bad token. Excuse me. And so what that's done is it's generated quite a few events in our audit log. And so this is a really clean, plain text sort of example of these are things that we want to capture. The new version of this application actually outputs things in JSON, so they're easier to parse. But this is just a simple pair. And it also generates metrics in Prometheus for quite a few things. And so we scroll down and we can see all of our login failures, login successes, secret fetch, all of these sorts of things. And so again, you can imagine, oops. I hate Prometheus so much. I didn't say that. No one heard that? There we go. There we go. Wow, that was hard. And so you can see our login failures jumped up to 4 in a very short period of time. There's a lot of really sophisticated things you can do with Prometheus as far as the alerting and things like that. I don't think I have any alerts set up on on this application. But in real life, you can track, if the number of login failures spikes over a very short period of time, create an alert, hey, something's probably wrong. You can create averages. Prometheus feeds into a bunch of forecasting things. It's not good yet, but we're actively working on making that better. And so, as you can see, we're generating the metrics, we're creating logs. I want to deep dive a little bit into Envoy, the Envoy configuration itself, and sort of how this application works on the SPIFFE side of things. And so there's a Docker file and a make file in this example repo. You call make environment, and it basically makes the demo for you. There is a script called register spire policy, and register Spire agents. And I mentioned that Spire is the open source implementation of SPIFFE. And so that's what we use for all of our examples. And the Spire policy at the highest of levels basically says for each known Spire node, we're going to allow a very specific application to run on that node. That application is given a SPIFFE ID, and that's what's assigned. The X509 certificate will have that SPIFFE ID, and then you can then use it to present to other things and use for TLS. And so we have a SPIFFE ID generated for simple secrets, which is our application. We have a SPIFFE ID generated for our Prometheus proxy, and we have SPIFFE created for our Fluent D proxy. And so if you go over here, this is a lot of text, but this is actually output from the Spire server. And so you can see in real time, it's signing our SPIFFE IDs or our SVIDs for these different applications. And again, these SPIFFE IDs are rotated every 2 minutes, I believe, in this example application. So it's the power of SPIFFE here is that we're programmatically generating private and public certificates. It's pretty cool. And with the rotation of every 2 minutes or something like that, this is significantly faster than anything you're going to be able to do by hand. There's a little bit of an overlap when it's generating the SPIFFE IDs. I think it's like 5 seconds or something like that by default, but you can kind of configure. So if your Spire server ever goes down, eventually things are going to stop working, but you do have some time to catch up. So it's not immediate. And so we can see our SPIFFE IDs are being generated. Oops. All right, so go back to our application. And so we can see here that we have our SPIFFE ID hard-coded. This is not actually what you would want to do in real life. You would want to parse the SPIFFE ID from the certificate that you're issued. But for this example application, this is just hard-coded into the application. I usually go into the Envoy config for all of the applications. They're kind of insane. So I won't go into too much detail about what they look like, but let's open up one really quickly. It's all YAML. I don't like YAML, but here we are. So Envoy, again, it's very much like Nginx, and so you will see a lot of the same, make this bigger, the same configuration options here. And so we have logging, we have static listeners, and we're creating listeners based on basically ports. And so, for instance, if your application is running on port 80 and you want to forward it to port 3000, you would have to create a single listener for that. And that's all this stuff means here. And so this is a listener for our application. The virtual host and the route, so very Apache-like, except in YAML, because of course. The important thing here is the TLS context. And this is what we're using to establish our TLS connections in between our applications. And so the verify subject alt name is the interesting part here. And so SPIFFE by itself doesn't mean a whole lot if you're generating these SPIFFE IDs, but part of what SPIFFE provides you is this API endpoint. And this API endpoint gives you access to the SPIFFE ID bundle. That bundle has basically public keys of all of the other valid SPIFFE IDs in that cluster. And so you can use that bundle to then verify any other SPIFFE ID that you come across. And so in this particular example, we're verifying the SAN of the Prometheus proxy. And we have another one down here for verifying the SPIFFE ID of the Fluent D proxy. And so the cool thing about TLS is that each end of that connection, or mutual TLS, each end of that connection can verify that it knows who each other is. And so there's a mutual identification thing there. And the SPIFFE IDs are just being pulled from the file system. Here, you can also do this programmatically now. And there's also some load balancing, but we won't get into that too much. And that's the simple server. On the other side, let's take Prometheus for an example. Again, it looks very similar. Listeners, it's listening for our simple metrics endpoint. If you've used Prometheus before, you know you have to create a metrics endpoint. And so Prometheus is connecting to that endpoint. Again, the SPIFFE ID bundle here. And we're verifying that the subject name of the certs for this particular tunnel is simple secrets 1. And because, again, that there, these things are cryptographic proof that you are who you say you are. And so if you don't have the SPIFFE ID in your subject alt name and it isn't a valid cert in this bundle, the connection will never establish. And so that's sort of the power of SPIFFE and Envoy together. So other than that, there's not a whole lot else to go over. Envoy is just a proxy, so there's not a whole lot to look at. There are quite a few metrics endpoints that you can pull from Envoy. It's one of the reasons why it's used for Istio is that it has this massive cache of metrics from, it understands HTTP, it also understands TLS, and so if you're trying to get connection and or higher level API things, but lower than say like an APM, you can typically use Envoy for that sort of thing. Right. Any questions from here? All right. I think that's probably all the detail I'm going to go into. There's a Rust example thing that I typically go into, but that's probably really boring, so I think I will end it here.
Does anyone have any questions for Sabree on application security?
Any questions?
Maybe even Docker security, one might say.
I'm not getting into that.
No, okay.
Runc has been my life for the last 3 weeks. I hate it.
Gotcha. Or anything else related to the talk this evening?
For sure. I know it was a lot of information. The way I typically present this is sort of like heavy in the slides, and depending on how familiar the audience is with the underlying technology, we can get a bit deeper. But otherwise, we're just staring at YAML, and that's not very fun. So it is what it is. Most of the sort of like the observability, I hate that word so much. Tools like FluentD, Prometheus, Envoy, all the cloud native stuff is configured with Envoy, is configured with YAML, excuse me, kind of moving away from JSON even. So it doesn't make for a very interesting demo, but it is what it is. Yep. He's giving you a mic. Because we're streaming and stuff.
So you were talking about the Envoy proxy. I was wondering if you've had any exposure to Linkerd.
They offered me a job. No.
So obviously you didn't accept?
No. No, Linkerd, in my opinion, is, if you are looking for a very simple solution for TLS in between your applications, it's great. Envoy, it can do so many things. And if you need that level of configuration, then Envoy is great for that. I think the big thing that Envoy provides, if you're building a platform, is a very rich API. They're pushing towards everything Envoy configuration being configurable by the API. And so if you need that level of extendability for some reason, it's kind of unmatched in that area. I will say the linkerd proxy is written in Rust. It's extremely fast. It's going to get faster when Tokyo gets his act together. I didn't say that. No, there's some pretty cool improvements happening to the underlying proxy. It's stupid. So if you're looking for really high performance, it's going to be pretty awesome. Any other questions?
I've got a question. Who here is not using technology like this today?
Yeah, it's I will say, like, going whole ham into the cloud native stack is, in my opinion, this is opinion, it's painful. But if you're deploying to Kubernetes, if you're deploying to Swarm or Mesos or inserting a number of containerized things, you kind of have to do it. So often metrics and logging and things like that in distributed manner are sort of the things you do after the application runs. Like, you do all the code changes you need to get it running on the platform and then deal with logging. Once you figure out that debugging things is extremely difficult and SSHing into things doesn't work. And so this is kind of like one of the first steps, and doing this stuff securely is even more difficult. But I will say, we weren't really concerned about security for a lot of the stuff to begin with. So it's just a concern that we're adding on top of it. Good. Any other questions? Cool. Well, I'm here. Have any questions afterwards and talk shop?
Thank you very much, Sabree.